The right orbital frontal cortex, that same structure that is for gleaming and beaming, is the senior executive of your thinking brain. Who'd have thought that the part of your brain involved in falling in love and social interaction is the thinking component of your nervous system? It's the senior executive of your ability to have impulse control, decision making. That term working memory is also homed or has its home in the right orbital frontal cortex. The ability to bring information from history, this will have great significance when I tell you this, into the front of my brain, work with it in the moment and make future projections is all part of this frontal cortex, okay? Being able to say, well, you know, the last time I did that didn't work out so well, and now I have a situation here in the moment that's kind of similar. Maybe I need to make a different choice. We call that self-reflection. The other structure that's really important in regulation is a bridge called the corpus callosum. There is a band, thick band, that help us move back and forth. It says, maybe I shouldn't tell my boss off today, or be able to acknowledge that you're feeling sad, or acknowledge that you're feeling uncomfortable. When this band is thinner, either due to fetal alcohol spectrum disorder or trauma, the ability to move back and forth between those two sides of the brain becomes harder. So your ability to have a secure attachment if you wanted one, your brain couldn't do it for you. It would be harder to be able to move information back and forth. Now, I mentioned to you earlier that in order for us to take care of and regulate ourselves, we need a frontal cortex, and we need another part of the brain that I started talking about that I'm going to pick up on now, called amygdala. This tiny little almond in your brain works so quickly that it comes online long before the cortex ever has a chance. Its job is to keep you alive. Amygdala scopes the scene of the environment around you and tells your brain, pay attention. So when the snake crawls in the room, your amygdala notices it. It doesn't know whether it's a garter snake or a rattlesnake. It just notices it as a threat or a potential threat. The job of the amygdala is to send out massive amounts of adrenaline to the rest of the brain and the body to get you ready for fight, flight, fright. So the architect of our nervous system played a big joke on us in that we are so easily upregulated and so slowly downregulated. It isn't until my right orbital frontal cortex gets in the game that I'll ever even have the ability to turn that amygdala down. Otherwise, I'm left with a raw Amy running the show. And that's what happens in fetal alcohol spectrum disorder. We've got an amygdala running the show without a frontal cortex to modulate its response. The other thing that you and I do is have a memory. Hippocampus helps you lay down new memory so that when you do something, you don't have to keep relearning it. The hippocampus, typically when there is a tremendous amount of emotion involved, takes one trial for you to remember because your survival depends on it. Except if I have FASD. This particular structure is one of the most damaged structures in fetal alcohol spectrum disorder, which means that the way that I store my memories are going to be inconsistent or diffusely distributed. It's not going to have a nice, neat file drawer to go back to and pull out. That's why sometimes they can do it and sometimes they can't. It depends on how much of that brain is regulated in the moment.